All right, hey guys, we're doing lesson 13, changing scales. For our opening exercise, there's an important thing to note here, this formula. To find the scale factor or constant of proportionality, we have to do the length in the scale drawing divided by the corresponding length in the original drawing. Describe using percentages the difference between a reduction and an enlargement. Well, when we see the words reduction and enlargement and percentages, we talked about that a little bit Monday and today. And I know that if it's, I'm going to write greater than, if we're greater than 100%, it's going to be an enlargement. And if we're less than 100%, even 99, 98, it's going to be a reduction. Okay. All right, let's kind of get started here. Use the two drawings below to complete the chart. Calculate the first row, drawing 1 to drawing 2 only. So in the chart here, we have this first row, drawing 1 to drawing 2. First box, quotient of corresponding horizontal distances. And the second box, quotient of corresponding vertical distances. Third box is the scale factor as a percent. And then we need to tell if it's a reduction or an enlargement. So to find the quotient of corresponding horizontal distances, I have to look back up here at my horizontal distances. Horizontal is like the horizon, so here's the 1 in drawing 1, and here's my horizontal distance in drawing 2. Now going back up to our formula, length in the scale drawing divided by the corresponding length in original drawing. So drawing 1 is our original, that's our first one, and this is our scale drawing. So I have to do my scale drawing, which is 3.92. 3.92 divided by the drawing 1, my original, which is 2.45, I believe. And I have to divide those, which will equal, and let me grab my calculator, 3.92, 92 hundredths divided by 2 and 45 hundredths equals 1.6. 1.6. Okay, and then the quotient of corresponding vertical distances, I'll switch over to purple. Here's my vertical, 1.5 and in the original and 2.4 in the scale. Scale comes first, so 2.4 divided by 1.5. 2.4, 1.5. Put this down a little bit and divide those. 2.4 divided by 1.5. That's also 1.6. And this is my decimal for both of them, 1.6. Box 3 is scale factor as a percent. So if I move it over 2 places, that's 160%. And I know that if it's greater than 100%, it's an enlargement. Okay. Now it says compare drawing 2 to drawing 1. So the scale drawing 2 to drawing 1. Use the completed work in the first row. Make a conjecture. Before I do that, compare drawing 2 to drawing 1. Use the completed work in the first row. Make a conjecture or statement about what the second row of the chart will be. Justify your conjecture without computing the second row. Well, if I look at it, I know drawing 1 to drawing 2 was an enlargement, right? It went from smaller to bigger. So I know a few things here. It will be a reduction, and the scale, and if I know that it's a reduction, the scale factor will be less than 100%. So I could tell that. Maybe change that to red so I can see it a little better. Okay, then it says compute the second row of the chart. Was your conjecture proven true? So now if we're going from drawing 2 to drawing 1, I'm basically going to flip these and do the 2.4 on top. 2.45 divided by 3.92. And over here I would do 1.5. 1.5 divided by 2.4. And we'll check these out with our calculator. Okay, 2.4 divided by 3 and 92/100ths. It's going to be kind of a long number, but 60 or 0.61, and I'm just going to round it off there. So 0.61. And the other should be the same, but let's check. 1 5/10 divided by 2 4/10. Did I do that correct? 1 5/10 divided by 2 4/10. 6. Oops. 0.625. So looking back at this, I must have typed something in wrong there. And this is also 6.25. That scale factor should have been the same for both, so I knew that there was something wrong. Okay, so 625 thousandths. And to change that to a percent, I would move it over 2 places, so it'd be 62.5%. And sure enough, that is less than 100, so this is a reduction. Was your conjecture proven true? Explain how you know. Yes, our conjecture was proven true because our scale factor was 62.5%, which means it was a reduction. Okay, on to example 1. The scale factor from drawing 1 to drawing 2 was 60%. Makes sense because 60% is less than 100, and I can see from my original to my scale, it got smaller. So it's a reduction. Find the scale factor from drawing 2 to drawing 1. Explain your reasoning. As you can remember, our original is always that 100%. And then from there, it can either be enlarged to over 100% or reduced, like this one, to less than 100% at 60%. So in order to find the scale factor in the opposite direction from here to here, I know that it's going to be an enlargement if I am starting at drawing 2 instead as my original and going to drawing 1, because I know I'll be getting larger. So I'm going to look at this. If I know my first one was at 100% and I know that the other percent I had was 60, I can divide my original percent from my reduced percent. So 100%, 100 divided by 60 is 1.6666 repeating. So this would be 1.6 repeating. And if I wanted to change that to a percent, because it wants us to find the scale factor from drawing 2 to drawing 1, and we've been doing the scale factor in percent, I'll move it over 2 places. And remember, this is repeating. So it would be, 166. And you could say 0.6 repeating percent, or remember, if it's a repeating 6, you could say 166 2/3%. Okay, so going from smaller to larger is going to be an enlargement, so I know that that looks correct. All right, example 2. A regular octagon is an 8-sided polygon with side lengths that are all equal. All 3 octagons are scale drawings of each other. Use the chart and the side lengths to to compute each scale factor as a percent. How can we check our answers? So if we look at this, each one of these boxes has the drawings that we want to use. So the first one is drawing 1 to drawing 2. I can see we have drawing 1 is the original, drawing 2, so whichever one we state is the original, and the second one is drawing 2. And if we look back at the very beginning, scale will be on top and the original will be on bottom. So which one was said first? Drawing 1, that was the original, so I'm going to put that on bottom. Original is on bottom. And the scale, 12 length, I can see 10, 12, and then on drawing 3, the side length is 8. Okay, so drawing 1, original is on bottom, drawing 2 on top. So 12 divided by 10 is 1.2, which equals, as a percent, if I move it over 2 places, 120%. And that makes sense because it is getting bigger, so it is an enlargement. Our equation to illustrate the relationship would be, remember what we learned the other day, the original times the percent, our scale factor, which would be 1.2 equals 12, which is the other side length. Okay, now we're doing drawing 1 to drawing 3. So again, our original is 10. Original goes on bottom. And scale is 8. So that will go on top. 8/10. Looks like this is a decimal. And 80% as a percent. Our equation would be original. So 10 times that 0.8, the scale factor, 80% equals 8. All right, we're on a roll. Drawing 2 to drawing 1. So now drawing 2 is the original, which was 12. Drawing 1 was 10. So let's divide those and see what we get. 10 divided by 12 is 8.333 repeating. Or, sorry, 0.83 repeating. Okay. And as a percent, we'll move it over 2 places. So be 83 and 1/3, because repeating 3 would be 1/3 percent, or 83.3 repeating percent. And our equation would be our original, which is 12 times 0.83 repeating equals 10. All right, drawing 2 to drawing 3, and 2 to 3. So the original was drawing 2, which was 8. Drawing 3 was the scale. Oh, whoops. Drawing 2. I did that wrong. Drawing 2 was not 8. Drawing 2, the original was 12. Excuse me. And drawing 3 was 8. So the first one goes on the bottom. Our original goes on bottom. 8/12. 8 divided by 12 is 6 repeating, 0.6 repeating. Which equals 66. And 0.6 is repeating is 2/3 percent. Our equation would be our original 12 times 0.6 repeating equals 8. Okay, scale drawing 3 is now our original, which was 8. Scale drawing 1, which I believe was 10. And then if I divide those, 10 divided by 8, 1.25 is a decimal. Which is, whoops, or 1.25 which is 125%. And original 8 times 1.25 equals 10. And that should be an enlargement from drawing 3 to 1. 3 to 1, yep, is an enlargement. And then our last one is drawing 3 to drawing 2. Drawing 3 again was 8, that's our original, goes on bottom. And drawing 2 is 12. This one's going to be over 100 as well. 12 divided by 8 is 1.5, or 1.5. And as a percent would be 150%. Our equation for that would be our original of 8 times 1.2, not 25, 1.5 equals 12. Okay. Oops, too far. Here we go. Example 3, and this is our last one. It says the scale factor from drawing 1 to drawing 2 is 112%. Here's that 112. It's from 1 to 2. Makes sense. It's an enlargement, so greater than 100. And the scale factor from drawing 1 to drawing 3, 1 to 3, was 84%. Okay, reduction, yep. Is drawing 2 a reduction or an enlargement from drawing 3? So if I started with drawing 3 and I went to drawing 2, just looking at it, I can see, or it looks like it is an enlargement. This one looks smaller than this one, but it tells us justify your answer using the scale factor. The drawing is not necessarily drawn to scale, so they're saying these might not be actually the appropriate sizes. So first I need to find the scale factor of drawing 3 to drawing 2, and I can use my 2 scale factors that I already know. I know 112%, which is 1.12, and I know 84%, which as a decimal is 0.84. Should change this one up here, 1.12. And I'm going to take my original, drawing 1 to drawing 3, the original, and put it on the bottom, 0.84, and my my scale, 1.12, and put it on top, and divide those. Okay, let's try it. 1.12 divided by 0.84. And that gives us 1.3 repeating. And I'm trying to find the scale factor, so I'm going to change this to, repeating. I'm going to change this to a percentage, so if I move it over 2 places, it'd be 133. And if the 3 repeats, it'd be 0.333, or 1/3%. So this would be 133 and 1/3%. And that does prove that it is an enlargement. Okay. And down here it says, explain how you could use the scale factors from drawing 1 to drawing 2, the 112%, and from drawing 2 to drawing 3, 75%, to show that the scale factor from drawing 1 to drawing 3 was 84%. Okay, well, if the scale factor from drawing 1 to drawing 2 is 112%, I'm going to type this out. If the scale factor from 1 to 2 is 112%, and the scale factor from 2 to 3 is 75%, I have to find 75% of 112% to get from drawing 2 to drawing 3. So I can do, I'll have to change these to decimals, but I could do 0.75. And when I see I know that I'll be timesing. So 0.75 or 75% times 1.12, which is 112%, and that would equal 0.84. Excuse me. Okay, so the scale factor from 1 to 2 is 112, and the scale factor from 2 to 3 is 75. To find, I have to find 75% from that original, 75% of this 2 to 3 at 75% to the times the 112% at 1.12. Another way that we could think about this problem is like the problem up here, where we knew the percentage scale factor from 1 to 2 was 60 because it was a reduction, and we had to figure out from 2 to 1 what it was. And I started with 100% for the original and divided by the percentage that we knew. So if I do it that way and I start with the 100% as my original being drawing 1, and then drawing 3, another way that we could show that is just like in that last problem. We had the original being the 100%, original goes on bottom, and then the percent from 1 to 3 was 84, so I'll put that on top. And if you divide those, you get 0.84. So that's another way that you can do that problem. Okay, we will be working on a few extra practice problems as well as the exit ticket in class tomorrow.